Okay, guys, we're going to do one more method of factoring these trinomials where the a coefficient is greater than 1. It's the least effective method. It's the method I would suggest using as a last option most of the time, but it does have its use. It's an educated guess and check. It's not just a random guess and check. It's educated. You're going to use a little bit of a system to try to figure this out. You may have noticed that when you did some of the problems in the first two methods in either the a times c and factored by grouping or the slide divide slide method, when you did the a times c product, sometimes you get a really large number, numbers that you didn't really know many factors of. So I would use this educated guess and check when that a times c product is very large, some number that you don't know factors of very well. What you're going to do is you're going to list the factor pairs for A and C terms. You're going to list all the A factor pairs and the C factor pairs. Then you're just going to start picking, and you're going to guess. You're usually going to start with the factors that aren't the largest. You might use them, but it's rare. It's not as often. You're probably going to use the factors that are closer to the middle pairs. You'll see what I mean. And you'll start filling them in. And you're going to check with FOIL. You're just checking the outer and the inner to see if they make that B term. And here's the educated part. When you make your binomials, you cannot have a GCF with the numbers you put in. If you have a GCF with the numbers you put in, that means that your problem had a GCF to start. And we're going to talk about that tomorrow. So there's no GCF in the numbers you put in. So that's going to eliminate some of the options right away. Let's take a look at a couple. Here's one of the ones you did. 15n squared minus n minus 1n, if you want to put a 1 there, minus 28. So I know I'm going to subtract to make 1 eventually. Well, if you were to do that a times c, whether you use either of the first two methods, you're multiplying 15 times 28. And that product is 420. I don't know about you, but I'm not a big factors of 420 kind of person. So I'm not going to use the a times c method. I'm not going to use either of the first methods. I'm going to start guessing and checking. So I'm going to list over here all the factors of the a. A is 15, so the factor pairs are 1 and 15, or 3 and 5. That's it. It has two factor pairs. And over here, I'm going to list the factor pairs of c. So it'll be 1 times 28. It'll be 2 times 14. 3 won't go into it, so it'll be 4 times 7. And now I'm going to make my little parenthesis template. I'm going to fill in my variable, my n, and my n. I know that I'm going to have different signs because I have a negative c, and I'm going to subtract to make 1. So I'm going to fill in different signs, plus and minus. I can always switch them later if I need to. I can reverse them. I'm going to start by filling in plus and minus. And now I'm just going to start picking factor pairs. Well, one of the things I said was, you're probably not going to use the largest pair. You're probably not going to use 1 and 15. You can always go back and use it if you have to, but I would start with 3 and 5. So let's fill in a 3 here and fill in a 5 there. Now you got to be careful. You have to make sure that these two numbers you fill in for factors of the a, so they have to fill in the first spots. You can't fill them in these lasts. You have to make sure you put in the right spots. All right, so I got a 3 and a 5. And then I'm probably not going to use 28 and 1. I'm probably not going to use 2 and 14. I'm probably going to use 4 and 7. So I'll try it. But I can't have any GCFs. In other words, 4 can't have a GCF with either 5 to put it in here, or 3 and put it in here. Well, fortunately, it doesn't. So I don't have to worry about that. So 4 and 7 are my factors. So I'm going to fill them in, 4 and 7 in those last spots. And now I check my outer and my inner and see what I get. Well, my outer product gives me negative 12, n, and my inner product gives me a positive 35n. Do they subtract to make 1? No. So I know that this pairing is not right. So I'm going to do some erasing. And instead of doing the 7 there and the 4 there, I'll reverse them and see what happens. I'll put the 4 here and the 7 here. And I'll check them again. Now my outer gives me a negative 21. And my inner gives me a positive 20. And guess what? Negative 21 plus 20 is negative 1. And I got my answer. Jackpot. These are my factor pairs that I used. And I managed to make it work. I kind of got lucky. I didn't have to use any of these other pairs. But sometimes you have to keep on trying until you get the one that works. That's why it's called guess and check. Let's take a look at another one. You did this one on one of the worksheets. 10w squared minus 19w minus 15. Well, if I multiply the a times the c, I get 150. Not terrible. It's not as bad as 420 was, but still, 150. I need factors to subtract. They make 19. Probably not going to bother with that. What I'll do is I'll start filling in my template. I'll fill in my w and my w. I know I need a w and a w. The negative on the c term means I'm going to have different signs. So I'll fill in a plus and a minus. And I'll start factoring. The factors of 10 are 1 and 10, and 2 and 5. And the factors of the c term are 1 and 15, and 3 and 5. And now I'll pick and start trying them out. Again, you might end up using the 1 and the 10 or the 1 and the 15, but I never start there because those are the less common ones. So I'm going to start filling in the 2 and the 5. The 2 and the 5 go in the first spots with the variable because they make the 10 with the w, or w squared. So I'll put the 2 there and the 5 there. I'm going to fill in my 3 and my 5 in my other spots. But remember I said you can't have a GCF anywhere. So when I fill in 3 and 5, in this spot here, I can fill in the 3, but I can't fill in the 5 because this 5 that I would fill in here and this 5 have a GCF. So I eliminate my option of putting 5 there and 3 there. So I'll put the 3 here and the 5 there. And I'll check them and see what my outer and inner give me. Well, let's see, my outer, 2w times negative 3, gives me negative 6w. And my inner, 5 times 5, gives me positive 25. And hey, guess what? 25 minus 6 is 19. But it's positive 19, and I need negative 19. That means that my two numbers are opposite signs. That means that my two signs are backwards. So I'll take the plus and make it a minus, take the minus and make it a plus, and just double check. Now, 2 times positive 3 gives me positive 6, and negative 5 times 5 gives me negative 25, and that gives me negative 19, and I got my answer. A lot easier than trying to figure out factors of 150, which would have been 25 and 6. Well, it might have worked. Sometimes this works faster. Sometimes it doesn't. Got one more for you. This one's kind of nasty. 48x squared plus 22x minus 15. Well, if I multiply the a times the c, I get 720. Besides like 72 and 10, 80 and 9, 90 and 8, I don't know a lot of factors of 720, especially not ones that subtract, they make 22. So trying to multiply a times c to do either slide, divide, slide, or factor by grouping, probably going to be a lot of work. So here's another option where I'm going to guess and check. So I'm going to fill in my x and my x. I know that my negative c term means I'm going to have opposite signs of parentheses. One will be a plus, one will be a minus. And as you saw before, you can always reverse them if you need to at the end. I just put plus first, minus second. It's just what I do. 48's got a lot of factors. Let's see. 1 and 48. Probably not going to use that one, but I'm going to list it just to make sure I have it. 2 and 24. 3 and 16. 4 and 12. and 6 and 8. I got 5 pairs of factors here. A lot of things to guess with. So I wanted to be educated about this, not just going to randomly do it. I'll make my factory list here. This is 1 of 15, and 3, and 5. So because I have fewer pairs over here, I'm going to start with these instead of starting with these. And I'm going to say, okay, probably not using 1 of 15, probably using 3 and 5. So I'll fill those in. But now these are the C's, so they're the lasts. So 3 and 5. And now I go over here and I start saying, okay, what pair am I going to use? Well, I'm going to start with 6 and 8. See how it goes. Well, 6 and 8 is great, but I can't put 6 here. If I put 6 here, 6 and 3 have a GCF. So I can't go 6 and 8. I have to go 8 and 6. Okay, so you can't have that GCF. Never going to work that way if you're solving the problem correctly. All right, let's check my outer and my inner. 8 and negative 5 gives me negative 40. 3 and 6 gives me positive 18. Oh, what's that give me? Gives me negative 22. But I'm trying to get positive 22. Okay, let's just use my plus has to become a minus, and my minus has to become a plus. Double check to make sure you're good now. 8 times positive 5 is positive 40, and negative 3 times 6 is negative 18. And now it gives me a positive 22x, and there's my answer. If this hadn't worked, if 6 and 8 hadn't worked with 3 and 5, I would have crossed it off. I would have gone to 4 and 12, and I would have filled them in and tried them. Same thing though. The 12 can't go here because a 12 and a 3 would have a GCF. So I'd have to put the 4 there and the 12 there, and then check them and see how it came out. So sometimes this guess and check, educated guess and check method has a value. When the product of A times C was 720, and you need to know that the factor of 720 is subtracted to make 22 were 18 and 40, you probably weren't coming up with that anytime soon. This actually was probably easier that way. So just another option. It's not the most fundamentally sound option. It's an option that you'll never get taught in a math book because there's no validity to it. There's no like perfect algorithm to it. It's a guess and check. Math books don't like guess and check. Sometimes guess and check does have merit if you're willing to do it educationally and intelligently. So another option, see how you do today.